Have you ever wondered what lies beneath the vast, dark expanses of the ocean? In places where no sunlight penetrates and pressures crush with unimaginable force? These regions, known as the Hadal Zone, plunge from 6,000 meters to nearly 11,000 meters deep, forming some of the most extreme and enigmatic environments on Earth. Imagine staggering depths where the darkness is absolute and the temperature hovers just above freezing. It's not just a cold and silent void. This abyssal realm is teeming with life, albeit stranger and more mysterious than anything we encounter on the ocean's surface or even in shallower waters. What kinds of creatures might lurk there, in blistering cold and under pressures 1,000 times greater than at the surface? These are the questions that fuel both scientific discovery and the imaginations of those who dream of the unknown sea. The Hadal Zone is primarily composed of oceanic trenches, long, narrow, and steep-sided chasms carved deep into the planet's crust by tectonic forces. Take the Mariana Trench, the deepest point in the ocean, reaching almost 11 kilometers beneath the waves, far deeper than Mount Everest is tall. It's a place almost alien in its conditions. Pressure here is so immense it would crush a human body instantly, and darkness reigns eternal. Yet, astonishingly, life exists in these crushing depths. Biologists and oceanographers have only just begun to understand how organisms survive and thrive here, adapting in ways that seem like science fiction. These creatures aren't just surviving. They're flourishing in conditions previously thought impossible for life. Scientists have begun to explore these depths with submersibles and remote sampling technology that reveal a world unlike any other. Strange, glowing fish with translucent bodies and jaws lined with needle-sharp teeth drift silently in the blackness. Tubeworms cluster around hydrothermal vents, where mineral-rich water bursts from the Earth's crust at temperatures that fry most life forms. Yet these vents host vibrant ecosystems fueled not by sunlight but by chemosynthesis. In the Hadal Trenches, new species continue to be discovered: peculiar clams, giant amphipods, and creatures that resemble both insects and crustaceans, all adapted to extreme pressure and near-freezing temperatures. These discoveries pull back the curtain on a world once thought utterly inhospitable, revealing a resilience of life that is both awe-inspiring and eerie. The Hadal Trenches, while isolated in some ways, are not closed systems. Recent findings show surprising connections between the deep ocean and surface activities. For instance, some deep-sea amphipods, gigantic, shrimp-like creatures, have been found to ingest microplastics, evidence that human pollution has reached even these remote habitats. Moreover, organic matter from sunlit waters slowly descends as marine snow, nourishing the life forms below. Methane seeps, cold vents, and chemical plumes shape unique niches in these trenches, creating small oases of life in an otherwise hostile seascape. It's a reminder that even the deepest trenches are linked inextricably to events above the waves, as if the ocean remembers every ripple of the surface world. But what would happen if tomorrow new forms of life emerged in these depths? Could shifts in ocean chemistry, driven by climate change or tectonic activity, trigger rapid evolutionary leaps? The Hadal Zone's extreme isolation and harsh conditions make it a crucible for unexpected forms and strategies of survival. Imagine biological designs that challenge everything we know: creatures with metallic skins that deflect pressure, or bioluminescent displays so hypnotic they lure prey into inescapable traps. Such visions border on nightmare and wonder, evoking creatures that feel almost extraterrestrial. The ocean's darkest frontiers could soon reveal these forms, born from millennia of unseen adaptation and sudden environmental upheavals. Exploring these depths is a marvel of human ingenuity and courage. Submersibles operated remotely or piloted by humans dive into these abysses, enduring crushing pressures and navigating unfamiliar terrain. Every expedition reveals traces of life, fragments of ecosystems, and clues to Earth's evolutionary history. But much remains hidden. The Hadal Zone is vast, and technology, while advancing, can only scratch its surface. This mystery deepens the suspense and fascination. Each dive could uncover a living fossil or an entirely new lineage of sea creatures. What secrets lie in the darkness, awaiting discovery? The Hadal Zone is a reminder that our planet remains largely unexplored, its wonders far beyond human imagination. The unknown depths beckon like a cosmic horror story yet to be told, a frontier where the laws of physics and biology are pushed to their limits. The creatures of tomorrow's deep sea may not resemble anything seen before, evoking awe, curiosity, and a sliver of fear. How will these organisms interact with their environment and with other forms of life? What adaptations will they carry to endure extremes of pressure, cold, and darkness? For ocean explorers and scientists alike, the Hadal Trenches offer a cradle of mystery, a place to study life at its most resilient, yet also to confront the sublime terror of the ocean's hidden realms. So as you ponder what new sea creatures might emerge tomorrow, remember that the ocean's darkest corners are alive, hidden ecosystems teeming with bizarre life, where nature plays out its greatest dramas in silence. This is a realm where science fiction meets fact, where every discovery raises deeper questions. The Hadal Zone reminds us that exploration is not just about finding answers, but about awakening wonder and fear about the unknown. As we send our machines and submersibles deeper, perhaps one day soon, humanity will glimpse these new creatures firsthand, revealing the ocean's secrets and expanding the frontier of life itself. Imagine a creature so small it could easily be overlooked in the vast ocean depths, yet so deadly it wields a weapon unlike anything else in the sea, a venomous harpoon. These remarkable predators are deep-sea gastropods, a type of sea snail recently discovered at depths around 380 to 400 meters near New Caledonia and Vanuatu in the South Pacific. Among the family of turrid gastropods, these snails use an incredibly specialized radula tooth, shaped like a microscopic spear or harpoon, which they launch with deadly precision to inject toxins into unsuspecting prey. It's hard to believe that such delicate creatures could survive, let alone dominate, in one of Earth's most unforgiving environments. But their adaptations show the strange paths evolution can take under extreme pressure and darkness. These harpoon-like teeth are no ordinary anatomy. They're part of an extraordinary hunting mechanism. Serpent-like and swift, the tooth extends out from the snail's mouth, striking with lightning speed as venom courses through a hollow channel directly into the prey. The venom itself is a complex cocktail of peptides and neurotoxins, capable of paralyzing or killing fish and other small sea creatures almost instantly. This precision chemical warfare is not only fascinating but also terrifying, as there's no known antidote to these toxins. The venom's potency serves as a chilling reminder that survival in the deep often comes at a brutal cost, where every hunt is a deadly gamble between predator and prey. One might wonder, how could such a slow-moving creature even hope to catch faster prey? The secret lies in their remarkable stealth and ingenuity. These gastropods appear slow and unassuming but rely on camouflage, blending into their surroundings with shells patterned in mesmerizing designs that make them almost invisible against the ocean floor. Their prey, often unsuspecting fish or worms, doesn't sense the impending doom until it's too late. This deadly ambush strategy reflects the quiet terror of the deep sea, where patience and venom replace speed and brute force. The mere thought of these snails lurking in the shadows, waiting and poised to strike, adds a layer of suspense and horror to this alien marine world. The discovery of these venomous harpoon gastropods is especially thrilling because their venom holds promise beyond natural history. Scientists have long been fascinated by the medicinal potential of marine toxins, and some related species' venom peptides have already contributed to breakthrough treatments for chronic pain and even cancer. These toxins are exquisitely designed to target specific nervous system receptors, making them valuable tools for drug development. It's a paradoxical twist that something so deadly in nature might one day save or improve human lives. This connection between the horror of a venomous attack and the hope of medical breakthroughs captures the enigmatic duality of nature's dark designs. But what if, tomorrow, new variants of these harpoon-holding snails emerge? Could changes in the ocean environment, such as temperature or chemical shifts, push their evolution in unimaginable directions? Perhaps there are harpooners with enhanced venom cocktails, able to immobilize larger prey or even defend themselves from the ocean's fiercest predators. What if their venom evolved to include properties that disrupt the nervous systems of complex organisms far beyond their usual victims? The mere possibility pulses with a mysterious and eerie thrill, stirring the imagination with visions of nightmarish hunters swimming silently in the deep, armed with invisible, paralytic weapons. Researchers exploring the abyssal depths near Australia are already on the hunt for new species with harpoon-like teeth, suggesting that our knowledge of these predators is just the beginning. Using submersibles and remote-operated vehicles, scientists collect specimens and observe behaviors deep below the surface, expanding our understanding of how life adapts under conditions that would be lethal to most creatures. Every new discovery adds pieces to an unsettling puzzle, a predator-prey arms race hidden from our eyes in the ocean's twilight zone. The deeper we peer, the more it becomes clear that the ocean conceals dangers as well as marvels, and these venomous snails embody both in their silent, lethal existence. While these gastropods are fascinating from a scientific perspective, their very existence serves as a cautionary tale. Their habitats are vulnerable to human impact, such as deep-sea mining, pollution, and climate shifts that disturb delicate ecosystems. Overharvesting for collectors fascinated by their striking shells also threatens their populations. Despite their small size, these creatures play vital roles in maintaining the balance of deep-sea ecosystems, and disrupting them might have unforeseen ripple effects. The presence of such potent venoms and specialized adaptations reminds us how fragile and extraordinary deep-sea life can be, both a treasure to be studied and a mystery to be respected. So as we imagine the ocean's future, these venomous harpoon gastropods challenge us to look beyond familiar creatures and ponder the mysteries lurking beneath. They are living reminders that even in slow, seemingly insignificant beings, evolution crafts weapons of uncanny precision and danger. Their story is a testament to nature's inventiveness, blending beauty and terror in ways that captivate and unsettle us. Will tomorrow's oceans harbor even stranger hunters? Only time and deeper exploration will tell. But for now, these silent, deadly snails remain one of the ocean's most fascinating enigmas, harbingers of the unknown in the shadowy depths. Have you ever heard of a creature so bizarre it seems plucked from the darkest corners of a sci-fi horror story? Meet the death ball, a carnivorous sponge recently discovered in the freezing, crushing depths of the Antarctic Ocean. Unlike the gentle, passive filter feeders most of us associate with sponges, this spherical monster uses hundreds of tiny hooks on its surface to trap unwary prey, mostly small crustaceans and other tiny sea dwellers. Found about 3.5 kilometers beneath the waves near Montague Island, these eerie sponges cling silently to volcanic calderas, waiting for the slightest brush from an unsuspecting victim. It's a haunting image, a ball of silent death drifting in the pitch-black abyss, where slow, painful digestion seals the fate of those it snares. The death ball sponge challenges our traditional view of sponges as simple, harmless animals. Its unique predatory behavior, something entirely new in the ancient sponge lineage, disrupts what we think we know about these creatures. Most sponges feed by filtering water for microscopic particles, but this one has evolved an almost sinister method of survival, actively hunting in one of the ocean's most hostile environments. The microscopic hooks on its spherical surface act like biological Velcro, snagging anything that drifts too close, immobilizing it slowly over hours or even days. This slow, inevitable doom adds a layer of horror to its existence, a silent trap from which there is no escape. Why would a sponge become a predator at depths where food is scarce? It's a question scientists are eager to answer as it speaks volumes about life's adaptability. The Antarctic deep sea is an extreme environment. Perpetual darkness, freezing temperatures, and immense pressure make survival incredibly difficult. In such challenging conditions, the usual filter feeding might not provide enough energy, forcing some species to evolve more aggressive and specialized hunting techniques. This evolutionary twist highlights a cruel logic. Only the most inventive survive. It's a chilling reminder that the ocean's depths are arenas of constant struggle, contrasting starkly with the peaceful image sponges usually evoke. The discovery of the death ball sponge came as part of a recent expedition using the ROV Sebastian to explore remote seafloor habitats around volcanic islands and trenches near Antarctica. Scientists collected thousands of samples, but this sponge stood out like a ghostly sentinel of the abyss. Its unusual shape and predatory nature have earned it a fearful nickname, but its ecological role might be crucial. In these dark, food-limited environments, Carnivorous sponges could help regulate populations of smaller crustaceans and maintain balance in the fragile deep-sea ecosystem. The discovery underscores how much remains unknown in the ocean's remote corners, where new forms of life continue to baffle and amaze. Alongside the deathball sponge, researchers found other peculiar creatures that add to this undersea horror story. Among these were zombie worms, which lack mouths and guts, instead relying on bacteria to digest whale bones, illuminating a weird food chain based on decomposition in the abyss. Scientists also observed iridescent armored worms, unusual sea stars, and vibrant coral gardens nestled around hydrothermal vents where volcanic activity fuels life in unexpected ways. These ecosystems thrive despite the relentless cold and pressure, showcasing life's incredible resilience. Each new species discovery adds another chapter to the mystery of how life perpetuates itself in the ocean's darkest, most hostile realms. What does this mean for the ocean's future? The Antarctic deep sea, once sealed beneath thick ice, is opening up due to climate change and shifting ice shelves, revealing habitats that haven't seen sunlight for millennia. This exposure invites new exploration but also raises concerns about how disturbing these environments might impact these fragile species. Could future changes provoke rapid evolution or even spawn new types of predators like the deathball sponge? The possibility is both thrilling and unsettling. Nature might respond to changing conditions with radical adaptations, creating creatures stranger and more terrifying than anything we've seen before. More than just a shocking oddity, the deathball sponge helps scientists understand the complexity of deep-sea food webs and biological interactions that stretch our understanding of marine ecosystems. Its slow, grim method of feeding acts as a symbol of the relentlessness and subtle cruelty that defines life in extreme environments. The sponge's presence forces us to reconsider ecological frameworks and the evolutionary arms races happening silently in the dark. For those fascinated by the ocean's mysteries, this discovery is a potent reminder that the abyss is far from lifeless. Rather, it's a theater of astonishing, sometimes horrifying biodiversity waiting to be unraveled. So when you think of sponges, discard the image of harmless blobs quietly filtering water. Instead, picture these death balls lurking in the shadowy Antarctic depths, poised to trap and consume with venomous dread. They are living metaphors for the ocean's unchecked power and mystery, silent hunters in a world utterly alien to us. As ocean exploration advances, we can expect to uncover more such creatures that combine beauty and terror in equal measure, expanding our understanding of life's endless capacity for innovation and survival. The deathball sponge invites us to embrace curiosity and acknowledge the ocean's dark, unknowable secrets that still lie beneath the waves. Have you ever wondered how creatures survive in the terrifying darkness of the deep sea, where sunlight never reaches and the pressure could crush a human in an instant? One of the ocean's most iconic and mysterious predators is the deep-sea anglerfish. These bizarre creatures look like something straight out of a nightmare, with grotesque features and a glowing lure that they use to attract prey in the pitch-black abyss. Despite their monstrous appearance, anglerfish have evolved fascinating adaptations that make them perfectly suited to this harsh environment, turning fear and mystery into evolutionary artistry. What secrets lie behind their ghastly visage, and how do they thrive where few others can? The anglerfish's most famous feature is the elysium, a modified dorsal fin ray that sticks out above its head like a fishing rod, with a glowing tip called the esca. This bioluminescent lure is packed with bacteria that produce light, and by jerking it back and forth, the anglerfish mimics the movements of small prey to entice other fish and crustaceans within reach. This clever strategy allows the anglerfish to sit motionless, conserving precious energy in a realm where hunting is challenging and food scarce. Imagine the terror of a tiny fish, drawn to a strange, otherworldly glow only to be snapped up by sharp, fang-like teeth that seem too large for the anglerfish's body. Ambush is the anglerfish's game. With an enormous mouth lined with needle-sharp teeth angled inward, prey has almost no chance of escape once caught. Their jaws and stomachs are highly flexible, allowing them to swallow creatures larger than themselves whole, a vital adaptation when meals can be few and far between. Anglerfish are patient hunters, waiting in eerie silence to snatch whatever unlucky animal strays too close. This lethargic, energy-saving lifestyle suits the low-energy environment of the deep sea, where food falls from above in slow, unpredictable drifts or wanders into the anglerfish's deadly range of influence. Another astonishing adaptation involves the extreme sexual dimorphism and reproductive strategy seen in many deep-sea anglerfish species. Males are tiny compared to females, sometimes only a few centimeters in length. In a life-or-death twist, the tiny male will seek out a female and attach itself permanently to her body, eventually fusing and becoming little more than a sperm-producing parasite. This bizarre symbiosis ensures that when a female anglerfish is ready to reproduce, she has a mate instantly at hand. It's a reproductive strategy born of necessity in a vast, dark world where encounters between individuals are rare and precious. Far from just a one-trick predator, some anglerfish species have complex strategies to confuse predators or rivals. Their bioluminescent lure can also serve as a defense mechanism, distracting or confusing attackers long enough for the anglerfish to escape. Additionally, some anglerfish species possess venomous spines, a deterrent to predators that might otherwise risk a meal with them. Despite their fearsome hunting adaptations, anglerfish are themselves vulnerable to deep-sea predators such as sharks and larger fish, maintaining a delicate balance of life and death in the dark ocean depths. Biologists believe the anglerfish's grotesque and alien appearance evolved not only for hunting efficiency but also as a way to blend into the deep-sea environment. Some species resemble corals or pieces of twisted seaweed, perfect for ambushing curious prey. Others rely on the eerie glow of their lure to mimic small, slow-moving creatures, enhancing their role as masters of deception. These evolutionary tricks underline the strange beauty of life where every adaptation is a key to survival in an extreme world so unlike our own. As the ocean and climate change on the surface, scientists speculate about how anglerfish and other deep-sea predators might evolve in the future. Could new environmental pressures lead to even stranger forms, with more elaborate lures or deadly mechanisms? Might the anglerfish develop new tactics to survive increasing competition or changing prey availability? These questions spark both awe and unease. As the ocean's darkest realms remain a frontier of mysteries, some beautiful but others terrifying, waiting to be unlocked. The tale of the anglerfish reminds us that the deep sea is no barren wasteland but a vibrant, terrifying ecosystem full of ingenious hunters and strange survival stories. With every new discovery, we peel back another layer of nature's ingenuity and cruelty, understanding not just how life endures but how it thrives in the shadows. It is a world that teaches us to respect the unknown, to marvel at evolution's creativity, and to brace for the extraordinary creatures waiting in the depths. Those who will capture our imagination, perhaps inspire a chill, and forever change how we see life beneath the waves. The ocean's hydrothermal vents and abyssal frontiers conjure images of a world where life defies logic and thrives under conditions that would annihilate most other organisms. Imagine a sinister, alien landscape. Scalding jets of mineral-rich water spewing from the seafloor, surrounded by darkness so complete it feels suffocating. Yet, around these volcanic chimneys, vibrant ecosystems flourish, fueled not by sunlight but by chemical energy. Hydrothermal vents are the front line of life's daring conquest into the ocean's most extreme and inhospitable realms. What strange creatures call these vents home, and how do they survive in such a hellish zone? At these seafloor oases, life turns to chemosynthesis instead of photosynthesis. Instead of relying on sunlight, microorganisms harness the energy from compounds like hydrogen sulfide emitted by the vents. These microbes form the base of an ecosystem unlike any terrestrial one. Giant tube worms with red plumes, resembling alien towers, house symbiotic bacteria that provide nutrients. These towering creatures, reaching up to 2 meters, depend entirely on their internal bacteria, making them biological wonders of mutualism. The eerie, twitching motion of tube worms in pitch-black water evokes a scene of living sculptures in a shadowy, toxic underworld. But the mystery does not end with tube worms. Around these vents crawl crustaceans with armored shells, ghostly fish with translucent bodies, and peculiar mollusks adapted to poisonous waters. Some species have evolved unique iron sulfide teeth, durable enough to scrape tiny microbes off chimney surfaces, a gruesome adaptation to a deadly environment. Each organism reveals Darwinian ingenuity bent to extreme ends. The ocean's abyssal frontiers are a reminder that life not only survives but creatively flourishes even in the harshest settings, twisting and reshaping life forms into strange, fascinating designs. Scientists exploring these vents often report a sense of awe mixed with unease, encountering creatures with almost monstrous appearances and lifestyles. Blind shrimp pack their claws with venom, defending territory in a place where lightless silence reigns. Meanwhile, predatory fish lurk in cave-like depressions, perfectly camouflaged to ambush passing prey. The vent's mineral-rich plumes create chemical fogs, making fishing for food equal parts art and chance. How life negotiates such perilous challenges remains a profound mystery, deepening the ocean's aura of horror and fascination as an ever-changing crucible of survival and death. Life around abyssal frontiers also highlights the interconnectedness of ocean chemistry and biology. Volcanic activity under the ocean continually reshapes these habitats, creating new vents and destroying old ones, sparking evolutionary pulses. Organisms here must be adaptable and resilient to survive not just the dark and pressure but sudden cataclysms. Some species produce spores or cysts that can lie dormant through catastrophic events, a biological insurance policy. This cycle of destruction and renewal at the ocean's edge casts the deep as a landscape not just of stillness but of violent possibility and persistent change. But how might these extreme ecosystems respond to future ocean changes? Scientists warn that warming waters, deep-sea mining, and acidification threaten these fragile environments. Could stressors push species towards rapid mutation or entirely new evolutionary paths? The potential for horrific new forms, perfectly adapted to altered conditions, sparks both excitement and fear. What secrets does the abyss hide now, waiting for altered chemical tides or tectonic shifts to unlock bizarre new players in this life drama? The abyss's chilling unknown beckons both curiosity and dread, a dark frontier awaiting our exploration. Despite their otherworldly nature, vent ecosystems contribute vital insights about life on Earth, and possibly beyond. By studying how life persists in such inhospitable places, scientists gain clues about life's origins and potential existence on other planets. These discoveries challenge assumptions about where life can thrive and how resilient it really is, pushing the boundaries of biology. This underscores a haunting yet hopeful message. Even in darkness and danger, life invents endlessly, weaving fragile webs of existence in defiance of extinction. As the ocean's abyssal frontiers slowly reveal their secrets, they invite us to rethink the mysteries beneath the waves. These vent habitats and toxic vents are not just remote curiosities, but essential chapters in the story of life's tenacity. They prompt wonder, fright, and respect, reminding us that the future ocean's new forms may be stranger and more enigmatic than we dare imagine. In the pressure cooker of the seafloor, life persists. The abyss waits quietly, promising revelations that will challenge and captivate all who dare to look. As we look toward the future, the oceans beckon us with mysteries yet to be revealed, and the creatures of tomorrow's deep sea promise to challenge everything we think we know about life beneath the waves. Climate change, pollution, and the relentless march of human activity are rapidly transforming marine ecosystems, applying evolutionary pressures that may birth equally extraordinary and strange new marine forms. Could warming waters spark the evolution of creatures with enhanced heat tolerance or entirely new biochemical pathways? Might acidification and oxygen depletion force adaptations that resemble science fiction, creating species with novel survival strategies that push the limits of biology? The ocean's future is a vast, unfolding canvas where nature will paint in bold, unpredictable strokes. Genetic engineering and synthetic biology may also play roles in shaping tomorrow's marine life, raising questions that blur the line between natural evolution and human intervention. Already, scientists experiment with gene editing in aquatic species to bolster their resilience or productivity. But what happens when such technology meets the deep, unexplored ocean? Could we see hybrid creatures that combine natural and synthetic traits, adapted for survival in altered oceanic conditions, or even for resource harvesting? These possibilities awaken a sense of both wonder and wariness, echoing age-old fears about playing God with nature. amplified by the mysterious depths where few eyes can see. Environmental changes can accelerate evolutionary processes in astounding ways. Rapid shifts in temperature, salinity, or nutrient availability may create isolated pockets where species quickly diverge and adapt, spawning entirely new lineages. In such crucibles, bizarre phenotypes may arise, bioluminescent shells like eerie lanterns, limbs adapted for crawling on acidic sediments, or even intelligence levels higher than expected for deep-sea invertebrates. With oceans warming and currents shifting, what strange creatures might emerge from these isolated evolutionary laboratories will both dazzle and unnervingly surprise us. Moreover, the ocean's unexplored depths are so vast that entire ecosystems remain hidden, their composition shifting subtly over time with tectonic and chemical changes. Hydrothermal vents and cold seeps erupt and collapse, forging new habitats where life can originate anew in geologic moments. These extreme frontiers serve as nature's grand evolutionary experiment, where creatures that push the edge of biology persist. The shadows between these habitats likely harbor new forms of life that challenge classification and provoke humbling questions about what it means to survive and thrive in such extremes. The intricate webs tying oceanic life together mean disruptions cascade unpredictably. Introducing or losing key species can upend food webs, opening niches for strange new creatures to evolve. As humans impact the oceans through overfishing and pollution, opportunities arise for hardy, opportunistic species to adapt and proliferate, sometimes in ways frightening and unfamiliar. Will future oceans see the rise of enormous, gelatinous predators that drift silently through warming waters, or genetically modified organisms released into the wild escaping human control? The dynamic between stewardship and unintended consequences will shape not only marine life but the human future itself. The mysterious edge of tomorrow's marine life is not without its deeper philosophical implications. These new forms, magical and monstrous in equal measure, force us to grapple with the profound unknown inherent in all life's evolution. They reveal a universe where beauty and horror intertwine, where survival demands inventiveness bordering on the alien. Exploring these new frontiers challenges human imagination and scientific rigor alike, demanding humility in the face of life's complexity and unpredictability. As technology improves, so does our ability to observe and study these emerging creatures. But the deep ocean's vastness guarantees many secrets will remain stubbornly concealed. Robotic explorers, autonomous sensors, and remote labs might one day illuminate habitats that currently pulse only with faint, eerie glows in the dark, revealing creatures strange enough to rewrite textbooks. Yet, the eeriest lesson may be that life continually evolves beyond our predictions, leaving us both excited and apprehensive about what new forms lie waiting in the ocean's most hidden corners. So, as the future of life beneath the waves beckons, we stand on the cusp of discovery and wonder. The oceans will continue to surprise, captivate, and challenge us with new creatures born of change, mystery, and evolution. The haunting beauty of the deep is a reminder that life is endlessly creative and enigmatic, a story unfinished and open to infinite possibilities. What waits tomorrow is a question that invites us to look deeper and to listen closely to the whispers of the unknown ocean's future.